Hey guys, my name is Nicholas Drake, and I spent the better part of well actually not the better part, more than the last year working on this day sequence plugin. So today, yeah, we're going to cover just a bit of background on it, talking about like why we created the plugin, what problems we're trying to solve with it, and giving some context on how we use it in Fortnite, and how that kind of informed the development process. That's just going to be a few minutes, and then we'll mostly spend this talk on a demo, just running through like the basic workflows and usages of it in a sort of sample level I put together for this. So yeah, we'll hop into the background for it. So day sequence is effectively the successor to Fortnite's legacy time of day system. The legacy system it's an unnamed system that effectively does the same thing as day sequence, but in a little bit of a different way. It had some problems with it. So the problem with the legacy system in Fortnite is that it really lacked any ability to be art directed, and so anytime we wanted to go and make changes to how things looked, or make changes on a per platform basis or anything like that, there was a really big workflow problem. Like artists would have these changes that they had proofed out and like blueprints and tested it, but when they wanted to go and put it in Fortnite, it often required engineering support because a lot of it was just baked into code. And so it really was a sufficient system for a long time, but whenever there was a big push to use Lumen in Fortnite, a number of problems popped up. So the first problem was making use of it in the first place. It required ongoing engineering support just to iterate on the look. And then whenever you introduce global illumination, you really change the lighting scenario in your game. So it doesn't just change like the quality or the fidelity of the lighting, but it really changes the distribution of light in the scene. And Lumen wasn't something we could turn on for all platforms all the time. And so we had this problem where we had environments with there was massive disparities in how everything looked. And so we had to solve that. And that was a really difficult problem to solve with the legacy system because it was just this hard-coded thing that was platform agnostic. And yeah, so day sequence had to be created. It wasn't called day sequence at the time. We didn't even know exactly what it would be. But now we're in the world where it's used for the majority of the Fortnite ecosystem. It's used in Battle Royale, Rocket Racing, Festival, UEFN, and there's an ongoing push to use it in all of the entire ecosystem. So what is day sequence? Day sequence is a plugin that adds day-night cycles to your game. A day-night cycle I'm going to define very loosely as something that basically takes the progression of time in your game, because most games have some concept of time, but it creates discrete units which are a single day cycle. Not necessarily a 24-hour thing. It can be whatever you want. We're trying to stay generic. But to address all of the issues that we had in Fortnite, we had to kind of adopt these three main development design goals. The first one is that it should be kind of decoupled from the rest of your gameplay logic. You should be able to design a game and basically build all of the gameplay, and it shouldn't necessarily depend on the implementation of your day-night cycle. And so, and we had this specific need to create day sequence and integrate it into Fortnite, which is a game that's existed for many years now, and it's iterated on very quickly. We release seasons frequently, so we didn't have time to go and rebuild all of the gameplay systems that depended on the time of day. So we had to mimic the old API, but we couldn't really prescribe certain workflows. We just had to try and stay generic. And so we have this emphasis on modularity because the previous system was a really monolithic system. Everything was kind of hard-coded in one place, and it wasn't easy to have multiple people working on it at the same time because you couldn't easily predict how changes might cascade out into the look. And so we emphasized this workflow where you create a bunch of small assets that kind of get used all together. And so what you can do is you can say, okay, I have this asset that defines how my clouds progress throughout the day, and then I might have something that defines how a particular biome in my world looks. And we want these to be separate from each other so that artists can work on specific parts of the world and make sure that they're not having these runoff effects. And then I have this versatile. These are all kind of buzzwordy, but I swear they're tangible. By versatile, basically what I'm saying here is these assets are, you have the ability to create these handcrafted assets that define like I said, a look in a desert or a look at a certain part of day, or maybe you're just doing the clouds. But we also have procedural sequence facilities to basically do things. I don't know if anyone's ever used the sun position calculator plugin, but it's something that lets you say, okay, I'm at this this latitude, this longitude on this day, and it will position the sun accurately. So we kind of took that kind of thing, and we allow you to generate sequences across a 24-hour or however long your day-night cycle is, to like create these baked sequences that you don't actually handcraft. You just feed it some data to create an independent sequence that does a specific thing. And this will be more tangible as I get into the example. But, so why use day sequence? Well, there's three primary workflows whenever you're using day sequence. These are basically like three phases that you're kind of moving back and forth between to focus on different parts. So this global control basically is it's the first thing you're going to do whenever you start using day sequence, and it's the stage of the design of your time of day system where you're defining how the day is going to look across the day-night cycle anywhere in your world all the time. And that's basically, like, most games can probably do that and get away with stopping there. Like, that's sufficient for, like, that in and of itself is sufficient to be a day-night cycle system. But we kind of took it further. So dynamic environments, this point's referring to something I'll show an example of. But there's this ability to go and dynamically like tweak the global system that you created based on these volumes we have. And so you can create biomes that are actually visually distinct from any other part of your world. And it all is kind of like, they use the same types of assets that you're using to define the global look, but you can just say, okay, I want this to be associated with this region of space. And then this responsive design point here is referring to the ability to hook up the day-night cycle to arbitrary external gameplay logic. And so the idea is you should be able to say, okay, I have this preset look, and I want to turn it on given some condition is met. We don't want the system that is basically like being evaluated. So an example of this would be a game that has like seasons, like summer, winter, spring, etc. Your game might have this seasonal progression, and it may already be built, and you just want to say, okay, now I want the look to change if the season changes. And so we have the ability to say, okay, I'm going to define this look, and I'm going to define some logic that evaluates my game state, and then we're going to make it respond to it. And so now we're going to just hop into a demonstration. And this demo will be two parts. First, I'm going to show you what we're going to work towards, like what's the end goal of this demo, and then I'll show you how I built it. So yeah, this is a simple little level I made. It's just like landscape and PCG, nothing super special. And there's a couple of key things I want to call out initially. Like, I have this actor here. It's a special actor, and I'll get into exactly what it is. Anytime this actor is present in your level, you get this new time of day like viewport bar. And so one thing that's important for us is that we are able to easily preview how the world's going to look in editor without having to like hop into Pi or package a build or anything like that. So immediately we can see that like I have this preview slider, and I can like move through the time of day. I'll actually like position so you can see the sun. The sun's kind of setting. You see it just like, I'm not like making the orange color. This is just a natural consequence of using a sky atmosphere. And then, so this is basically is kind of how you'll like scrub through that global look section. And then you'll see as I actually fly around, things can change. So I'm in this like desert region, and you can watch like the sun is going to, it gets a bit bigger and smaller, and the clouds fade in, and everything gets a bit brighter and more orange. And then I have this like that kind of foresty biome that I've created where everything gets foggier and darker, and like the cloud coverage increases. And yeah, and then just as an example of how we kind of hook up this system to respond to arbitrary gameplay logic, I have some really simple logic I created that with these actors, this is basically just like a bunch of collision shapes here that are going to cause some state change, and then the look responds to it. So this is like turning that forest look on. This is kind of reverting to the default look, and this section is kind of it's bringing that desert look. But the distinction here is that it's not associated with that desert biome. It's just turning a look on or off in response to some arbitrary game state. And so I'm actually going to show you what this kind of looks like under the hood. Day sequence it's a plugin that's entirely sequencer based. And the idea is you're managing a bunch of subsequences in this master like root sequence, which is responsible for defining your day-night cycle. So in the same way that I was scrubbing through this slider here, I open this root sequence and I can scrub through it, and it's going to move the sun, and it'll do everything. So I'm going to talk about how I created this later. It's a little bit more intuitive to follow the creation process as I do it rather than explaining how I got here. But you can build an intuition for how it works. Like, so I'll fly into the desert once again, and you see this desert sequence is like fading in and out, and it turns on and off based on like where I'm at in the world. It's the same for this forest region. There's a different sequence that's responsible for that forest look. And there's actually a way to preview like that overlap game state change. These colliders are doing the same thing as, actually I'll have to come back to that I think, but yeah, I'll just move on from that. Yeah, so let's just hop into an empty level that doesn't have any of this stuff. It just has the, we just have the world. So yeah, as I move around, there's no changes to the sky. As I'm in the desert, there's no time slider here. So how do I use day sequence? Well, first you would obviously turn the plugin on. It's a plugin that ships with 5.5 as experimental. I'm not going to turn it on here today because it causes an editor restart. But the first thing you need to do is add a day sequence actor. And there's a number of actors that we provide. So there is an actor called day sequence actor. And generally you don't use this unless you're creating one from like totally from scratch. It doesn't provide anything for you. It's fully configurable. The one we're going to use today is the sun moon actor. This is effectively just a sample actor we created to act as a jumping off point if you don't want to figure out how to use this plugin from like total scratch. And you can see there's something, everything's kind of weird here, right? Like everything's super bright. The sky looks wrong. I do have the slider, but things are seeming wrong. Like even at night, everything is super bright. And the problem is I still have these default lighting actors in the scene. And this is a very normal setup for our level. The day sequence actor, one of its responsibilities is to manage that set of lighting components. And so we have like a one-to-one match here between this set of actors here and the set of components on this day sequence actor. And so all I have to do is remove all of these, and we get a much more natural scenario here. So I'm just going to like move this actor into this lighting folder. And here we are. So now this is like, we're operating at that like global control phase of the workflow. So still, there's no like unique points of interest in the world. Nothing's changing as I fly around. It's just a static day-night cycle that we can preview, and it will play back if I enter pi. And we can open this root sequence here, and we can see there's really a minimal number of things inside of it. And now I can kind of, this is a good point to actually talk about like what's going on in here and how is it built. So the primary, other than owning these components here, the day sequence actor has really one other responsibility, and that's to manage the references to all of the assets that define your global look. And so there's this collection asset we created. This is a day sequence specific asset, and there's two arrays in here. The most important one is this top array here, and it has an entry in it for every single sequence in the root sequence that you created by hand. And so we see there's this DS 24-hour, and we see a one-to-one matching here. And if I go and add an entry here, nothing actually happens because it's empty. But I can actually show you how I might create, how might I do something like make the clouds denser at noon or something like that. And so I can easily come and create a day sequence. This is a type of sequence that is analogous to a level sequence or something like that, except it's got some unique qualities that I'll show you. So I'll call it like DS clouds or something like that. If I open this up, everything looks relatively normal. There's only one difference so far from a level sequence, and it's that we start with this generic binding to a root day sequence actor. What this means is it's not specific to a particular instance of a day sequence actor. It's actually going to be automatically bound to whatever day sequence actor is in your level. So these are actually reusable. They don't depend on a specific actor. And so if I go and do something like take my sky sphere, and then I get my sky material. The reason I'm doing this is because the clouds are driven by the sky material. Actually, that's incorrect. That's the stars. I'm going to do the volumetric cloud. That's what I want. The volumetric cloud material is where I define all the parameters that define how my clouds look. And so I can take this cloud coverage parameter here. I can delete this key. And so I want to do something like make it super dense around noon and then kind of fade out through the rest of the day. And so what I'll do is I'll drop like a keyframe here, and I'll give it a value of something like 0.5, like it's crazy dense. And I'll copy this, and I'll put 2 around it, and then I can drop this to 0, and I can drop this guy to 0. And then now as I scrub through, we see it fades in and fades out. That's all normal. Like there's nothing special going on here yet. So, but if I close this sequence, we see nothing's happening yet. That's because what I need to do is actually make sure it exists in this root sequence. So I've created this entry here, and then I'll go ahead and plug this in. And then immediately we see it show up in this root sequence. And so what's important to note here is this root sequence that we're editing here It's not actually an asset that you create yourself. It's a totally transient asset that's generated on the fly. And the idea is the reason we do that is because it's responsive to like where you're at in the world or the set of conditions that your time of day system is responding to. But the idea is it's managed for you and it's generated by the day sequence actor. And so the global phase of the authoring of your day-night cycle is defined by this collection asset here. And so when I say you're authoring the global look, it's basically, it maps to everything in this collection. And the reason we have multiple assets in here is because we want you to be able to modularly define things like how the clouds look or how like the material parameters for the sky are driven over the day cycle. And it really helps whenever you have many artists working in parallel on different parts of the look. These are the handcrafted assets I referred to earlier, but we also have these procedural sequences, and so this is where I called it the sun position calculator earlier. What I've done is I created a sun position sequence, and what it does is it has the same set of parameters exposed as the sun position calculator code, but instead of just setting the sun's position, what it's doing is it's actually generating a sequence that will position the sun in a physically accurate way. And so given this set of parameters here, this is my latitude, my longitude, and the date, and the time zone, etc., we can actually see that it's generated this sequence here. So I can take a look at the curves here, and this is you're looking at the components of the sun's orientation. So it's like roll, pitch, and yaw. And as I move through this is it's the sun kind of moving. And so, yeah, that's really basically the idea for authoring the global look. It's super simple. You can do anything you want inside those subsequences. So you can animate the look directly, or you can create event tracks which trigger things, which operate on external code. So it integrates simply into an existing game because it doesn't require that I do anything other than add the system into the game, and we can use the facilities that Sequencer has, because Sequencer is a really generic system for interacting with your world. So because we leverage it, anything can really be animated by this system. And so the natural question that follows then is, how do I do things like make my desert look different, right? Like how do I make my forest look darker? So it's a pretty simple process. There's an actor that we have called a day sequence modifier volume. So it's right here, and it's just, it starts out as a box. It can actually take on pretty much any shape you want. Any shape you want really actually means it can take on the union of any number of the collision shapes. So it can be a capsule component or a sphere or whatever. That's configured on this modifier component here. But all I have to do is make this box like super big. So I'll go ahead and I just do this by feel, like this. So now we kind of roughly encapsulate the desert. I'll kind of adjust it a little bit here. So we've defined this region of space. This is now like a point of interest in our world, but at least with respect to the time of day system. Let me turn off snapping. So how do I actually define the look? Well, just like I did before, I come and create a day sequence, and I can say, okay, I'm going to create this desert sequence. And instead of double-clicking this directly, because what you'll notice is that actually turns off our editor preview whenever we open a day sequence. Like we no longer see the global context of the look. So I'm not going to do that. There's a better way to do it. Instead, what I'm going to do is I'm going to come to this modifier volume, and I'm going to navigate to this user day sequence property here, and I'll drag this sequence on. And now as I fly into this, nothing happens yet. But if I open the root sequence, it's now in here. And so this is not managed by that collection asset. You can distinguish between them because anything that has this modifier prefix right here is something managed by an actor in the world. And this is the important detail for why the root sequence is a transient asset. It's because it's actually not something that's fixed at any point in time. It changes with respect to your position in the world or what time it is, or etc. So if I double click the desert now, the preview doesn't turn off. And so I have this in context editing. And so what I can do is I can grab those volumetric clouds again, and I can take the coverage and I can make it super low. I'll delete the key. I just want to set the fixed value over this entire day cycle. And now if I close this sequence, as I move in, it's really quickly blending. And so you can actually configure how quickly this is happening. If I select this actor here, there's this it's a poorly named blend amount property. So if I make this something bigger, like 1,000, this is basically saying from the boundary of my volume in world units, how quickly is it going to fade in or out. So 1,000 units from the boundary of this box is when the sequence will be fully on. So now as I walk in, it's much slower. And if I make it bigger, like 2,000, it's going to be a super slow process. And what I've done here is it's actually so big that I can't fully get that many units inside of it. And so the problem is it can't turn on fully. So if I do something like 1300, we get more reasonable values here. So I'm going to drop it down like to 1000 so I can do the full fade. And now I have this biome, and it's obviously distinct from the rest of the world. In this specific example, I'm not changing the cloud coverage over time, but that is something you're totally capable of doing. There's nothing stopping you from doing that. Yeah, so I'll just quickly I'll get it to parity with the example I had at the beginning of this. So originally, this clouds faded out, the sun got bigger, and it got more orange. And so what I'll do is I'll animate the light color of the light, and we'll make it something like kind of an orange color. And then we can animate the intensity of it, and we can make it something like 15. And then we've really simply, I mean, it's a bit of a silly example, but we've created this area of our world that feels different to the rest of the world. And we can do this same process all over the world. And I'm not going to make you guys watch me do that sequence creation process over and over. So I'm just going to reuse the sequence I created for this forest. But yeah, I'll go ahead and grab this. And so now if I come in here, it gets super dark. Clouds kind of, they don't get denser because at this point in time in the world, everything's already quite dense. But if I move to a time where the clouds aren't so dense, then there's this fading happening. So like everything is blending smoothly as I move around in the world. And so that's kind of the process we use in Fortnite often. So if you've played like the Wasteland, like the kind of Mad Max style, like vehicle season, we have this big volume around the desert where we do the same kind of thing as I'm doing in this desert here. And it's the same thing for like the Hades environment, etc. And it looks simple to use it, but you can actually achieve really interesting looks. And if you combine these volumes with external logic to turn them on or off, or if you control which sequences are active on them, you can actually create super dynamic environments. But so far, I haven't shown you how to control the look based on like game logic you may have already built. And so what I'm going to do right now is I'm actually going to swap this actor out for one that I've created, but I'm going to show you the differences here. So I'm going to delete this, and then I have this this blueprint actor here, which I'll open it up. You'll see that it is actually parented to the actor I just removed, so it's not very different. And the differences are very simple. I have this preset variable here, I have this event dispatcher, and then I have these two functions here. And when I say preset, I'm referring to a preset look for the world. And what I'm going to be doing is I'm going to be adding some logic that basically says, okay, I want the whole world to look like the forest now, but you could do something like, okay, I want to make it snowy now, and so you'd have a snowy sequence. And then you could have some gameplay logic that your game controls, and we can respond to it. And so all I have is I have this setter here, which sets this is getting the preset and returning it. This setter sets the preset, and importantly, we call this event dispatcher anytime the preset changes. This is an important detail. And that's it. That's all I've done. So otherwise, this actor is totally the same as the one I just removed from the level. I do need to do one thing, and I need to make sure we're using the same collection that we already created. So let me just swap it out. This comes with a different one by default, but there's no visual difference at the outside. So that's nice. We have this state now that's changing. It's like, so I need to go ahead and show you actually what is that preset. So that preset is just an enum that you define as an asset, and it has three possible values. It can be none, forest, or desert. So the point I'm trying to make is you can turn these looks on spatially, or you can drive it with game logic. And the way that works is I have this actor here, which is a silly actor called look setter, and I'll drop it in, and I'll scale it up a bit. And the idea is, I should probably uniformly scale this. The way this works is, all we're doing is whenever when I overlap any of these three components, we get the day sequence actor in the level. This is really simply just saying, this is an example of how you might interact with the day sequence actor from your game. There's a subsystem which is always tracking the current day sequence actor. So by default, it's going to map to the one you placed in the level. And then we're going to say, okay, is that actor our blueprint class? If it is, we're going to return it. If it's not, we're going to return nothing. And then in the event graph, all I'm doing is I'm saying if we overlap this desert collider, then we're going to set the preset to desert. If I overlap the forest collider, we're going to set it to the forest preset. If I overlap the disable collider, then we're just going to set the preset to none. And recall, this is just setting the value and calling the event dispatcher. And so that's like my fake gameplay logic that I'm basically going to show you how I respond to the changes. But importantly, none of that actually controlled the look, right? That's just totally separate to the sequences I've created, the day sequence actor. I mean, the logic happens to live on the day sequence actor, but nothing I've shown you yet actually controls how anything looks. And so the way you're going to associate particular sequences with a condition is we have these, there's a condition tag actor class. And so we can create blueprint classes, which are derived from this. You can see the parent class is day sequence condition tag. And I'll run you through how one of these works, but they work both effectively identically. Yeah, so here's an example. The condition tag is quite simple. You're going to implement two functions. There's an evaluate function, which lets you say, okay, I'm going to return true or false. True means the condition is true. False means the condition is false. You just have to decide, how do I actually determine whether or not the condition I'm representing is true or false? So once again, instead of going through the subsystem, I'm showing an alternate way of doing this. It turns out that condition tags are always owned by a day sequence actor, so you can conveniently get the outer and cast it to the actor. If it's our special actor, then we can continue with the logic. Otherwise, we just always return false. And then we say, get that preset enum, and if it's forest, then we return true. And if it's not forest, we return false. And so all this is saying is, if the current preset on the actor is forest, then we're going to say true. And then, because it can actually change at runtime, we need to know if it changes. And so there's this other function we can optionally implement, and this is going to give us an opportunity to monitor for changes. And so I called out earlier that that event dispatcher was important, and it's important because we're going to bind to it here. We're going to say if that event dispatcher is called, then we're going to invoke this function here. So broadcast on condition value change, it's a huge mouthful. I probably should have named it something different. But this is actually a function that lives on the parent class for a condition tag. It's not something you implement yourself. The idea is that you want to call it anytime the condition that you're checking may have changed. And we do this because we're not naively polling the condition. We don't want to check it like on tick or anything, because you can do very expensive things in here. And so we want to give you an opportunity to instead say, okay, now check it. So that's it. We've defined the condition, we've defined how to check some arbitrary game state, and we've defined how to listen for changes to the game state. And once we've created this blueprint, then we can go into our collection asset that is managed by the day sequence actor. It's this guy here. And we have the ability to say, okay, I have this forest sequence. I'm going to turn it on only when the forest look is enabled. And so just by creating that blueprint class, you don't have to do anything. Like everything I've shown you for that blueprint class is sufficient to have it show up in this menu here. And then we can say, all right, I want this sequence to be enabled anytime this condition is true. You notice a checkbox here. This checkbox actually allows you to invert the meaning of it. So if I turn this off, we'll see that now the forest is going to be on anytime this condition is failing. And because the preset currently is none, if I uncheck this, then suddenly this condition is considered passing. But if I turn this checkbox back on, it's only going to turn on when the preset is forest, and so nothing's happening yet. But if I pi in and I overlap this, remember this, by overlapping this collision here, it's going to call set preset forest, it's going to call that event dispatcher, and it turns the forest look on. And that happens because of what I've configured here. So, and it's really the exact same process for the desert. If I go into the desert condition tag, then I'm checking the exact same things, except instead of checking that I'm equal to the forest, I just check am I equal to the desert. But the monitoring logic is the exact same. So it's a bit of a silly example, but the idea there is you can evaluate arbitrary logic. So if you had an existing game that you'd already created, and in that game you've already implemented like 4 seasons, but you don't have the day-night cycle set up yet. Like you have this progression through the year, and you've created 4 different sequences that represent how it should look at each of those 4 states. Then you could create these condition tags, which are opaque to your game. Your game doesn't know anything about them, and you can monitor the state, and you can listen to it. And your game is just progressing through, the player's doing the player things, and the day-night cycle can easily say, okay, I'm going to like turn this sequence on now and turn this sequence on now. And I'll actually show you what I need to do really quickly is make these functions call an editor so I can prove to you that regardless of how I choose to do it, it works. So if actually there's no real good way to do it. So I'm going to do something really simply. I'm going to say like set forest. And what I'm going to do is I'm actually going to call set preset, and I'm going to choose forest, and then I'm going to call, and then all I've got to do is make this function call an editor. And we might notice something. Yeah, here we go. So now that I've made it call an editor, if I come and select my day sequence actor, we'll see I actually get a button here that calls that function. If I click it, it turns to forest. So the point I'm trying to demonstrate to you here is we have this forest sequence here. And actually I have no good way to turn that off. So I'm going to go ahead and let's say disable, and we're just going to say set preset, and we'll say none, call it, call an editor, compile. Sorry, there's a bit of an issue right now where whenever we recompile the blueprint for the actor, sometimes you need to reload the level. So I'll hop out and hop back in. Oh, actually, I'm not quite positive why. Yeah, sweet, everything's fine. There's a problem with occasionally if you recompile a blueprint that's managing a sequence, which happens to animate some material parameters, sometimes the material binding gets messed up. It's not actually a day sequence problem. Yeah, so the point I was trying to demonstrate there is if I come in, well, yeah, anyways, I'm actually going to move on from that. You get the idea. The idea is anytime I make the state change in a way that's monitorable by day sequence, the condition tags just have to be defined, and you can associate sequences with them, and it will work. So you can imagine that I could call that function from any other actor in the level, or I could have something like on tick, maybe I wait like 30 seconds and then it'll do it. It doesn't matter. Day sequence doesn't have to be doing that logic, it just has to be able to monitor it. And so I'm just going to kind of recap. The idea is we went through 3 different phases, right? Like I can come into this root sequence at any point in time and I can say, okay, I want to change like the sun intensity globally, right? And that works. Or I can make the clouds more dense. And then I can maybe come over here and say, okay, the cloud should be less dense over here, and then maybe more dense at night. And then as I move through the day, things change. And the idea is you can bounce back and forth between these different workflows and create interesting looks. And anytime you create these loose sequences, for example, something that like defines the look for a desert, because it's not actually associated with a particular day sequence actor, because it's actually animating this arbitrary root day sequence actor, you can have a totally different level or a totally different game and kind of port it over, and it works fine as long as it happens to have the same cloud material. So yeah, that's really the bulk of what I plan to show you guys today. I can, if you guys have any questions, I can try and like make something happen for you. Or if you want to talk about like more concrete use cases, I can maybe like talk about how you might do that.